right, this is on inverse and combined variations. So we've already studied direct and joint variation. So a third type of variation described is a situation in which one quantity increases and the other decreases. For example, the table that shows the time needed to drive 600 miles decreases as the speed increases. This type of variation is what we call an inverse variation. An inverse variation is a relationship between two variables, x and y, that can be written in the form y equals k over x. How we read this is y varies inversely as x. So again, one quantity is going to increase and then the other is going to decrease when we have an inverse variation. Example 1, y varies inversely as x, and we're giving you the value of y and x when you want to come up with the equation. So step 1, we write the equation y equals k over x. Step 2, we're going to go ahead and substitute the y and the x into the equation. So y is 3, x is 8, and then we solve this for k. So we're going to multiply both sides by 8. So k equals 24. Then step 3, we substitute the 24 in for k. So y equals 24 over x. And then there isn't a graph or something to answer. And then if we wanted to graph this by hand, here is what it would look like for that problem, y equals 24 over x. So you would substitute -3 in for x, so y equals 24 over -3, which is -8. And then you get the graph to look like this. Okay, example 2. The time t that it takes for a group of volunteers to construct a house varies inversely as the number of volunteers v. So we're going to go ahead and set up our inverse variation equation. So the time t varies inversely with the number of volunteers v. So let's go ahead and set up our variables. So t equals our time in hours, and then v equals the number of volunteers. Then they give us some values here. They say we're going to give you 20 volunteers to build a house, and the time will be 62.5 hours. So now let's go ahead and set up our equation. So this would be our y, and this would be our x. So in our inverse variation equation, it'll be y, which is the time, equals k over our volunteers Now we're going to go ahead and substitute our x and y into the equation. So again, that was time equals our constant of variation over the number of volunteers. So the time was 62.5 hours. The number of volunteers was 20. So there's a substitution. And now we want to find out what K is. So we multiply both sides by 20. So K equals 1,250. Now we're going to go ahead and take that constant of variation and substitute it into our equation. So time equals 1,250 divided by the number of volunteers. Now we're going to go ahead and answer the equation, or answer the question. So the question says, how many volunteers would it take to build a house with 50 working hours? So we're giving you the time, and we want you to find the number of volunteers. So the time is 50 hours, and we need to find the number of volunteers. So the equation will be 50 goes in for time, and we solve this equation for V. So what we're going to do first is we're going to go ahead and multiply both sides by V. And then we're going to divide both sides by 50. So we get V equals 25. So what we found is it takes 50 hours with 25 volunteers to build this house.